All right, in this video, I'm going to go over solving linear equations in one variable, or just with one variable. And I've listed the rules over here on the side. First rule is that whenever we are solving this equation, if we're going to add, subtract, multiply, or divide something, we need to do it to both sides of the equation. It's an equation because of this equal sign right there. And by both sides, we mean the right-hand side of the equal sign and the left-hand side of the equal sign. And most teachers will always refer to them as the left-hand side and the right-hand side. Now, another rule is we apply the distributive property as needed. I don't see any parentheses here. I don't think we need to do that for this one. Isolate the variable. That is our main goal, really. Multiply both sides by the coefficient. We'll get to that one eventually. Okay, so what do we do first? Well, we could do several things. Doesn't actually matter, so long as you follow these rules. Now, our main goal is to isolate the variable. What does that mean? It means to get the variable, which in this case is x. It's not always going to be x, but in this case, it is x. And we want to get it on one side of the equation. Doesn't matter if it's the left-hand side, doesn't matter if it's the right-hand side. In fact, we'll test that theory. I'll solve this equation twice. We'll do the left-hand side first, because that's what we like to do. We like to end our equations with x equals, not something equals x. But we're going to do it both ways just to demonstrate that there's no difference. So if we want the x to be over here, then we need to cancel this out somehow. How do we do that? Well, we need to get a 0 here. So we need to add 2x. Do you see that? If we're subtracting 2x and we add 2x, then we get 0x, which is just 0, because anything times 0 is 0, right? But I just did something to one side of the equation. I need to do that same thing to the other side. And why did I write it underneath that x, the 3x? Is because it's a like term. If you remember that, you can't add it to 17x. But technically, we are adding it to this entire side. And then we're adding it. But even though there's parentheses there, this isn't the distributive property because it's not being multiplied. We're just adding it. So we're doing 2x plus 3x plus 17 equals 0 plus 2 is just 2 on the other side. You see that? That is how you move the variable over to one side and isolate it. Is you got to cancel it out on one side and have it come out the other side with a slightly different value. It's not 3x anymore, it's 5x, because we combined like terms, right? 2x plus 3x is 5x. Bring the 17 down, bring the 2 down. All I did was combine like terms. There's no need to do something to both sides right there. Okay? Now, what do? Well, we need to get the x by itself. We need to get rid of this 17. We need to get rid of this 5. So let's get rid of the 17 first. So to get a 0 there, we subtract 17, right? Because we have positive 17, so minus 17 would be 0. And since we subtracted 17 from one side, we need to do that to the other side. So bring the 5x down. Oh, that was a terrible 5. 5x equals 2 minus 17. Negative 15? Yeah. All right, now this is where rule 4 comes into place. Whenever we need to get rid of, just whole numbers in general, we're trying to get 0, right? In this case, we don't want to get 0. We want to get 1 because we want 1x. Because 1 times x is just x, right? That's what we're going for. We're not going for 0 because 0 times x would be 0 and that would ruin our plan. So we multiply both sides by the coefficient. I think I may have written that down wrong. What we really mean is by the reciprocal. Because we're trying to get rid of this 5, right? And in order to get rid of a 5, we multiply by its reciprocal, which is 1 over 5, because every whole number is understood to be over 1. So the reciprocal would be 1 over 5. And 5 times 1 over 5 is 1, which is what we were going for. So multiply that by 1 over 5. Wow, man, I cannot write today. 1 over 5. And since we're multiplying this side by 1 over 5, we got to do it to the other side. Back to rule 1. These two 5's cancel. We get 1x. Negative 15 over 5, right? Negative 15 times 1, 1 times 5, negative 15 over 5. Are we done? No. We can actually divide this, right? 15 divided by 5 is what? Don't forget the negative. 3. There's your answer. Now, that was the left-hand side. What if we tried solving it going the other way and putting the x on the right-hand side? Will we get the same thing? Absolutely. But I'm just going to demonstrate it real fast. All right, just got rid of that mess so we're not confused. All right, so instead of adding 2x here, we're going to subtract 3x here to get 0. And since we did that to that side, we're going to do the same thing to this side, and we get 17 equals negative 5x plus 2. Minus 2, minus 2. 15 equals negative 5x. Another way you could look at this is you're just dividing by negative 5 to get 1x, right? 15 divided by negative 5 is negative 3. Same answer. It doesn't matter if you go with the right-hand side or the left-hand side. So, and another thing I should note is most teachers would prefer you get it on the left-hand side, probably. Even if you want to do it by the right-hand side, you can just flip this over and say x equals negative 3. Because it's the same thing, right? You can even use the rules to show that it's the same, right? Because we can add 3 to both sides. And we get 0 equals x plus 3, right? And we can subtract x from both sides. Negative x equals 3, right? And then divide by negative 1. X equals negative 3. I just used our rules to prove that no matter which way you write an equation, it will mean the same thing. Okay. And that's the right-hand side. All right, we'll do another one. All right, here's another one. Now we're going to apply rule number 2 because there are parentheses. So we need to distribute when there are parentheses. So 20 times x, 20x, 20 times 1, 20. That was easy. 3x, oh, 17 times x, 17 times 1, 17x plus 17 plus 3, okay. Combine like terms. Need to do all this stuff before we start isolating the variable. Got to do all like the normal simplifying things. So those are the like terms. Those are like terms, right? So 3 plus 17 is 20x. 17 plus 3 is 20. Wait a minute. Isn't that exactly what I have on the other side? This is no good. Well, we need to isolate the variables, so I guess we haven't yet. So let's try. Minus 20x, minus 20x. Uh-oh. That becomes 0, and that becomes 0. What did I just do? 20 equals 20. What is the purpose of this problem? Well, it's to show you that sometimes you don't get one answer. Usually you get one answer, but sometimes you get a true statement. And this leads us to the 5th rule. If you get a true statement, then the answer is all real numbers. If you can read that. And you can write out the words all real numbers, or you can do a little symbol like just big R with a circle around it. And I've seen lots of teachers use this symbol. It means all real numbers. It means you could put any number in here and it will work. X equals 1. 1 plus 1 is 2. 2 times 20 is 40. So that's 40 on that side. 3 plus 34 plus 3 is 40. Yep. So, and I bet you could do that with any number for x, just as long as both x's are the same. You can't, or all the x's are the same. You can't just put in -2 here and a 1 there. No, that's not going to work. All the x's have to be the same. So that's our 5th rule. Okay, well, if there's a true statement, is there a possibility of getting a false statement? Yes. All right. For this one, let's practice this again. Here's parentheses, apply the distributive property. -2x. -2 times -12 is +24. Okay, we got -2x minus 5 on this side. Okay. Well, let's get the x over on the left-hand side. Do the same thing to both sides, and what happens? We get -5 equals 24. Oh, I hope not. False. So we have a false statement. What does that mean? False means there is no solution. No solution. And remember how to spell false. So it is possible that you get one answer when solving these equations. It's possible to get an infinite number of answers, and it's possible to get no answers at all. But no solution in itself is the answer, is the solution. So you better remember to write no solution on your test and circle it. All right, in this next example, I'm going to go over something that I think is important. And that is that you may remember PEMDAS, the order of operations. You know, parentheses, exponents, multiplication, division, addition, subtraction. Well, so far we've been doing addition and subtraction first. We haven't been doing multiplication and division. Why is that? Why is my first instinct when solving for x to subtract 1 first? Well, PEMDAS doesn't really apply here. You know, we're just trying to isolate x. We can do whatever we want. But what if we did do that? Is there a reason why I'm subtracting 1 first? What if we divided by 2? Well, we run into a problem here because we're dividing this whole side of the equation by 2, right? And we're dividing not just the 2x divided by 2, we're dividing this whole thing divided by 2, which would be technically the distributive property. So we're multiplying 1/2 times that and 1/2 times that. So we get x plus 1/2 plus -9/2. Now that just gives us fractions, which is just making it harder on ourselves. Now this is a very simple problem, and you can just subtract 1/2, and you get what? -10/2. Well, I'm thinking ahead. -10/2, which becomes -5. But why did I have to distribute it? Well, we're applying it to both sides of the equation. Like I said before, we have to. With addition and subtraction, if you apply it to the whole side of the equation, like 2x plus 1 equals -9, and you're just subtracting 1, you don't have to subtract 1 from here because you kind of are. You're subtracting 1 from this whole side. It's just you are applying the distributive property. It just doesn't really apply to addition and subtraction. That's why it's a little easier to do that first. So that becomes 2x. This becomes -10, right? We divide both sides by 2, get the x by itself, because that cancels and becomes 1, right? -10 divided by 2 is -5. See? And I just proved that if you were to divide, you have to apply it to both terms in that side, the whole thing. You have to distribute it, or you won't get the right answer. But my advice to you would be to do it this way over here, because it just makes it easier on yourself. All right, maybe one more and we'll call it a video. All right, one more. Distributive property first. Multiply that by 4, multiply that by -5. 4 times x is 4x. 4 times -3 is -12 plus 12. Oh, I can already see that's going to cancel out like terms. 15 minus -5 times x is -5x. -5 times +6 is -30. Okay. -12 plus 12 is 0. 15 minus 30 is -15. Plus 5x to get 0, right? Plus 5x. (9x) plus -15, right? Divide both sides by 9. And we've got x equals -15 over 9. That doesn't divide out evenly. But are we done? No, we need to reduce that, because 15 over 9 is not a simplified fraction. They can both be divided by 3, right? So -15 divided by 3 is -5. 9 divided by 3 is 3. So the answer is -5/3. All right, and this is just to demonstrate that your answer is not always going to be a nice whole number. Sometimes you're going to get a fraction. All right, thank you for watching.